Here's a review video on the worksheet that we've been doing in class. So just in case you're at home and you don't know how to solve some of these problems, you can watch this video to help you out. Okay, I'm going to start with number 1. It says find the measure of angle A. Find the measure of angle A. So in some of these problems, right, in numbers 1, 2, and 3, we look at the triangle and I see measure or angle A is right here. And in number 1, it says 5x. Angle A is 5x. But we don't know what that x is going to be, right? So we have to figure out how can we use all three angles, set up an equation to solve for x, and then plug it back in here, right? So that's kind of the game plan. We have to remember something we learned in chapter 1, the triangle sum theorem. Triangle sum theorem, which says all three angles in a triangle have to add up to 180. Add up to 180 degrees. Okay. So if I want to use that, equation here, I'm going to take this, and this, right? 5x plus 130 plus 3x plus 2. Those are the three angles, and I add them up and set it equal to 180. Okay, and then once I have my equation set up, I have to solve for x, right? So I see a bunch of terms. I see a bunch of terms on the left side of the equation. I want to combine some like terms here. So I see a 5x and a 3x, right? They both have x's, so I can just go ahead and add them up. 5x plus 3x, that's going to be 8x. I also see 130 and 2. Those are constants, just numbers, so it's going to add up to 132. Whatever I didn't use, I'm going to bring down. I didn't use a 180, so I bring it down, okay? Let's start taking away on both sides. I want to get my x by itself, right? So I need to take away 132 on both sides. I didn't use the 8x. 180 minus 132, that's 48. And we're going to divide both sides. This is 8. This is 8 times x, right? The multiplication is just kind of invisible. So the opposite of multiplying is dividing. We're going to divide by 8. Get x equals 6. But your final answer isn't 6. You have to go back, right? We have to go back here. Remember we said we want to find the measure of angle A. Angle A is 5x. So we're going to plug that back in. They're going to say 5 times 6 is going to be 30 degrees. 30 degrees, so your final answer is 30. Okay, so do the same thing in number 2 and 3. It's very similar to number 1. I'm going to keep going. Number 4, write a congruence statement for every corresponding angle and side of the two triangles. So 4, 5, and 6 are very similar to each other. So go ahead and kind of just, I'll do number 4 and then you use that to help you with 5 and 6, okay? So I have the triangles in front of me. I have triangle VWU, VWU, right? And I also have the other triangle VYZ, VYZ. Okay, so I know the two triangles are congruent because it says that here. Triangle VWU is congruent to triangle VYZ. But I just want to make sure I list the corresponding parts. Right, so we have angles and we have sides. So I'm going to go ahead and list all three pairs of angles. I see one pair here. I see this angle and this angle, right? But notice how they both share that point V. So what we're not going to do is we're not going to do angle V is congruent to angle V, right? Because if we say that, let's look at this angle V. Which one are we talking about? Are we talking about this angle on the left? Or are we talking about this angle on the right? We don't know. Okay, so we have to be a little bit more specific. We're going to include these other points on the triangle to specify which angle we are talking about. So angle, we're going to say angle UVW, right? If we say UVW, then it includes the other points, and that means we're talking about this angle right here, okay? So we're going to say angle UVW is congruent to, and I'm pausing here so you can figure out the next angle is going to be ZVY. Okay, ZVY, ZVY. Notice how I'm putting V in the middle, right? Because we're trying to get that angle. So if you want that angle, you have to put that point V in the middle, okay? Okay, let's keep going. And then I see 2 marks here on angle W, and I see 2 marks here on angle Y. So those 2 are going to be my congruent angles, my corresponding angles. And then the last one is U and Z. Okay, so angle U is congruent to angle Z. So I got all 3 angles. Now we're going to do the 3 sides. So I see this side right here, VW, has 1 mark. Has 1 mark right there. And then the other side, VY, has 1 mark. Right, has 1 mark right there. So again, those are my 2 congruent parts. VW is congruent to VY. The next one is U or WU is congruent to YZ, right? WU has 2 marks. Oops. And then YZ also has 2 marks. Okay. And then UV has 3 marks right here. And then ZV also has 3 marks. It is congruent to ZV. Okay. So those are the corresponding angles and sides for the 2 triangles. Okay, and all we're doing is writing congruent statements. You need practice with this because you're going to be reading this a lot. You're going to be writing this a lot in your proofs. So you just have to know what these mean. Okay. Okay, I'm going to keep going. 5 and 6 is very similar. Now I also want to say, right, for number 6, notice how there's no picture, but you still have to do the same thing. So remember, if I use number 4 as an example, you want to pay attention to the order of the letters in the statement here, right? Notice how W and Y are both the second letters on each triangle and they're congruent. Okay, and then also U and Z are the third letters and they're congruent. Okay, and then V is the first letter, but we're not going to say, again, we're not going to say, oops, angle V is congruent to angle V, so we have to include the other letters. We say U, V, W, Z, V, Y. Okay, so the order matters here. And then look at the sides. Look at the sides. Oops. There you go. 1, 2, 3. 1, 2, 3. And then same thing with the sides, right? VW are the first 2. VY are the first 2. UWU are the 2 and 3. And then YZ are 2 and 3. And then the last one is VU or UV is congruent to ZV, which is 3 and 1. Okay, so just recognize those patterns and use the same thing for number 6. Okay. All right, let's try number 7. 8, 9, and 10 are very similar to number 7. Okay, so I want you to go ahead and try out 8, 9, and 10 based on what I do in number 7. Determine if the 2 triangles are congruent. If they are, state how you know and justify your reasoning. So this is kind of like a mini proof, right? Whenever we do the proofs, we write like kind of a summary, a paragraph to show and explain and justify why the triangles are congruent. But here we're just going to state it and try to determine it. So if we want to show 2 triangles are congruent, we've been using little shortcuts, right? And we call them SAS or ASA, right? S stands for side, and then A stands for angle. So this one stands for side, angle, side. And this one is angle, side, angle. Okay. These theorems are shortcuts because if we go back to this question, right, if we wanted to show that two triangles are congruent, we have to, originally you had to do all of this. We had to say all three pairs of angles are congruent, and we had to say all three pairs of sides are congruent. So we have to list 6 different things. 1, 2, 3, 4, 5, 6. Right? But now these are shortcuts, right? Side, angle, side is only 3 things. It's only 3 things. Angle, side, angle, again, that's only 3 things. So we're going to try to use one of these theorems to show that these two triangles are congruent. So let's try it out. Based on the given information here, I see these two triangles. I see ABC, and then I see this one. Oops, no. And then so I see ABC, and I see the other one, BCD or DBC, whatever. All right. So I want to show that those two triangles are congruent. I see some marks here, right, for the sides, and I see a couple of marks for the angles. So let's start with those. Let's start with this side. I'm going to start with AC, right? I'm going to say AC is congruent to, on the other triangle, and what other side has 2 marks? It's going to be DC. AC is congruent to DC. And I want to justify each step, so I'm asking myself, how do I know these two sides are congruent? Remember, we always talked about how we use rigid motions to justify congruence. If I took this triangle and I reflected it across this line, it's going to flip over and reflect onto this side, okay? So we've talked about that a bunch of times before. If I had my tracing paper, I could show you, but for now, we're just going to say rigid motion. There's some rigid motion that takes AC to DC, okay? The next thing that was given to us was these two angles, this angle and this angle. We know because of the marks. Again, they both share that point angle C, so we're not going to say angle C is congruent to angle C. We're going to use, I'm going to use a different color. So we're going to say angle ACB, ACB, right? Angle ACB is congruent to the other angle, which is DCB, DCB. Okay, angle DCB. Same reason, right? There's some rigid motion that takes it from one angle to the other. If I were to flip, again, if I were to reflect this triangle over to this side across the line, it's going to show that those two angles are congruent. So I have a pair of sides here. I have a pair of sides, and then I have a pair of angles. So I just need one more thing. So I'm asking myself, I'm looking at this picture, and what's that last thing? And I notice I see this side. Both of the triangles are using this side in the middle, right? So that means that has to be congruent to itself. If both of the triangles are using it, it's the same side, so it's going to be congruent to itself. If you did your IXL already, you probably saw this in your IXL homework assignment. That's called the reflexive property. It's a reflection onto itself. So that's where the name comes from. Okay, so I'm kind of looking at my problem and I see, oh yeah, I used a pair of sides, I used a pair of angles, and then I use another pair of sides. So this is probably going to be SAS, right? SAS, side, angle, side. Side, angle, side. So now, again, we don't even need to figure out the rest of the angles and sides. All we need are 3 things. So we know the two triangles are congruent. Okay. Try out 8, 9, and 10. I will say, in number 8, you need to remember what vertical angles mean. Alright, you have to remember the definition of vertical angles. I'm not going to show you how to use it in number 8, but I'll give you an example. Remember, whenever we have kind of like this X shape here, the angles that are opposite from each other. So this angle, these two angles right here, are congruent, and then the other part, these two angles are congruent. Okay? Angles that are opposite from each other are always congruent. They're vertical angles. So you need to know how to apply that here in this problem. Okay, so try that out. Let you try that out. Okay. Okay. I'm gonna go down to number 11. So here, number 11, state what additional information is required to know that the triangles are congruent for the reason given. So number 11, we're using ASA, angle, side, angle specifically. So very similar to what we just did in number 7, right? But we want to figure out how we can use angle, side, angle here. So we're kind of working backwards. So again, I see these two angles right here. They have the 1 mark. So I'm going to state that angle EWV is congruent. EWV is this one up here. Is congruent to VWX, right? The other angle, VWX. So that's probably my first angle right there, okay? I'm looking at my triangle and I'm trying to see, where is my pair of congruent sides gonna be? Again, it's probably gonna be this side right here in the middle, where both of the triangles are using that same side. So VW is congruent to VW. Okay, that's the second part. So now we have a pair of angles, we have a pair of sides. Now we need another pair of angles. So where would that one be? So, and that last one is going to be right here. Okay, it has to be those two angles because it has to go in order. Angle, side, angle, right? Angle, side, angle. Okay, so let's go ahead and state that. We're going to say angle EVW, EVW is congruent to XVW, XVW. Oops. Okay, that's the third one, and that's kind of our answer here. That's the additional information we needed to know that the two triangles are congruent. So try the same thing for 12, 13, and 14. Okay. And then let's do a couple of these together. So I want to do 2 more questions, 15, 17, 15 and 17. And then, oh, sorry, not 17. Whoa, what that was going on. Interesting. Anyways, sorry. 15 and 19. Okay, let's do 15 and 19. So let's look at number 15. Find a measure of each angle indicated. I want to figure out what this angle is going to be, right? And we have some given information. We have some numbers here, 68, 139, 79, 84. But maybe I need to use some of those angles to figure out this question mark. So let's try it out. I want to figure out what these little missing angles are going to be. Maybe that'll lead me to this one right here. So I'm going to start with the one next to 139. I know, right, these two angles, when I combine them, they make this straight line here. So that's going to be supplementary angles. So I hope you're asking yourself, what do supplementary angles add up to? They have to be 180 degrees. So if that's 139, in my head I'm doing, what's 180 minus 139? Oh, that's 41. So that means this leftover angle has to be 41, right? Because 41 plus 139 is 180. Okay. And I'm doing another, now I'm trying to figure out what's this angle. Okay. I have this triangle. I have this triangle right here. Oh my God, what's going on? What the heck? Okay, sorry. I have this triangle right here, right? And we did this in the first problem. We said, what, all 3 angles in the triangle add up to 180. Okay, so I'm going to use that triangle sum theorem again to figure out this missing angle. So 68 plus 41, that's 9, that's 109. So these two together, 41 and 68, that's 109. I know all three of them have to be 180. So if I take away 109 from 180, that's going to be 71. Right? So that means this missing angle is 71 degrees. Bruh. Time out. 71 degrees, right? Okay, let's keep going. So now I'm looking at these three angles, and I want to figure out this missing one here. Sorry, I just dropped my marker pen. Now all those three angles, again, they have to add up to 180. So it equals 180. So I'm going to do the same thing. 71 plus 79, 0, that's 150. And if these both together are 150, what's the leftover? You have to subtract here. 180 minus 150, that's 30 degrees. So that missing angle is 30 degrees. Okay. And then I see another triangle here. I need to see another triangle. I'm trying to figure out all these colors, right? I see another triangle here. And I'm getting closer and closer to my missing angle. So I know, again, vertical angles, angles that are opposite from each other have to be the same. So if that's 84, this is also going to be 84. I see a triangle in here, so I'm going to follow the same steps. 30 plus 84, that's 114. And all three of those angles are 180, so 180 minus 114, that is 66. Yeah, that's 66. Sorry. So that's 66 degrees. Wait, this is 66. These are vertical angles. So that's 66. The question mark also has to be 66 degrees. Okay? Final answer. Okay, let's do this last one. Number 19. And then obviously what? From after number 15, 16, 17, 18 are all very similar. So go crazy, do that on your own. Okay, number 19. Find the measure of MPQ. Okay, angle MPQ is this outside one, right? Fun fact, this was your extra credit problem on your test, right? So not everyone had the chance to learn this, but it's okay. I wanted to challenge you. So I'm just redrawing this triangle. Let's do like a different version of this. Let's just say this is A, B, and C, and then this is angle D. Again, we know in a triangle, all three angles have to add up to 180, right? So if I take those three angles, A plus B plus C, that's going to equal to 180. But I also know that angles C and D, they're supplementary, right? Supplementary angles. So that means that they have to add up to 180 again. So the idea is if these two equations, if they're both equal to 180, can they be equal to each other? And that the answer is yes, they should be able to, or they should be equal to each other, right? If I'm 6'2" and you're 6'2", we're both 6'2", right? That makes sense? That makes sense? Okay. And then, so if we set those equations equal to each other, and then I take away C on both sides, because there's a C on both sides. If I take away C, let's see what happens. This was your extra credit question. If you did these steps, you could have gotten your extra credit. I think like 3 people got it. Then you get A plus B is equal to D, right? So the idea here is this angle plus this angle is equal to the outside one. So if we want to use that in our problem, we're basically just going to say 40 plus 3x plus 11x equals 16x plus 8. This is called the exterior angle theorem. Okay? So clearly the 16x plus 8 is on the outside of the triangle, right? So that's what it's saying. Exterior angle theorem. It's the exterior angle is equal to the two inside ones, the sum of the two inside ones. So let's go ahead. We have our equation. Let's solve for x and then plug it back in. I see 40 and 30 like terms, so that's 43. Kind of run into an issue here. I see an x on the left side. I see an x on the right side. I don't need one on each side of the equation. So let me combine, or not combine like terms, but let me just get rid of it on one side. Okay, I'm going to subtract 11x on both sides to get rid of it on the left side. 16x minus 11x, that's 5x. Okay, now I have x on the right. Let's go ahead and solve for it. Minus 8, minus 8, 5x equals 35. And then, you know these steps, divide by 5. X equals 7. Okay. But the question said find the measure of MPQ. Okay, so let's go ahead and plug it back in. Oh no. 2, oh no. 2, 16x plus 8. So MPQ is 16x plus 8. 16 and x is 7. So 6 times 7, that's 42. That's 112 plus 8. So our final answer here is 120. Okay, that's it from me. Goodbye.